Hey everybody. Let's continue with the graphs of trig functions. Excuse me. Again, let's make sure that you have your unit circle handy or a table of values for tangent. Either way, I wanted to highlight going through some cycles of tangent. Okay, so let's look at it this way. I'm going to go on the x-axis from 0 to pi over 2. As you look at your unit circle, the positive x-axis is 0, the positive y-axis is pi over 2. Now because tangent is y divided by x, that's rise over run, which is another way to think of slope. So let's think of it this way. If you have a flat line, its slope is 0, and that's at 0 degrees or 0 radians. As you work your way up to 30 degrees, 45 degrees, 60, and on your way up to pi over 2, if you were to trace that motion with your hand or a pencil, you'll notice that your angle gets steeper and steeper, and it's positively inclined. In fact, it gets steeper and steeper until you get to pi over 2, which becomes vertical. Now, a vertical line has undefined slope, and so we've made a note of that in a previous video where tangent of pi over 2 was undefined. As you work your way around from pi over 2 into quadrant 2, going all the way from pi over 2 to pi, the moment you get left of pi over 2, your graph is negatively but steeply sloped, and the closer you get to pi, the less your slope becomes. And when you get to pi, you're back to a flat angle, which has a slope of 0. So that's to kind of visually explain why these graphs of tangent have streaks that oscillate. They're based on the slope of an angle. Some are steep and negatively sloped. Some are flat, which is 0. And some are positively and steeply sloped, and that's these upper parts. These red dashed lines are not part of the graph. Those are called vertical asymptotes. You probably heard that in college algebra. Every odd pi over 2 is a vertical asymptote for tangent. It's every time you hit a vertical angle at 90 or 270. In radians, that's pi over 2 and 3 pi over 2. Okay, it's a little bit harder to write the domain because the domain of sine and cosine was infinite, negative infinity to infinity. It's defined everywhere. Tangent is not the same. So, the domain of tangent is any angle x such that the angle is not pi over 2 or a distance of pi added or subtracted. N can be any integer. So as long as your angle is not pi over 2 or a multiple of pi away from it, your function's defined. But if it does fall on pi over 2 or any multiple of pi away from it, it is not defined. Now these streaks go up and down forever. Your range is infinite, negative infinity to positive infinity. There is no amplitude for tangent, and its period is pi. The distance between the asymptotes is pi units, and that's the distance it takes horizontally for a graph to run one cycle. If you flip the graph of tangent upside down, it will look the same, meaning it has symmetry at the origin and it's an odd function. If the lead coefficient is negative, then these streaks flip those across the x-axis. They will have the same basic appearance, but they will streak in opposite directions. Instead of up and right, they will streak down and right. Half x, because the period for tangent is pi, you're only going to do pi divided by that coefficient. For sine and cosine, it was 2 pi divided by the coefficient, but for tangent, it's only going to be 1 pi divided by the coefficient. Pi divided by half is 2 pi, so that means between the asymptotes, you've got to run a total distance of 2 pi, and that's how far it is between the asymptotes. For this one, the domain is pi, the domain is any angle except for pi or any 2 pi multiple away from it. Because of the period is 2 pi, any 2 pi multiple away from pi, you're going to have a vertical asymptote and the function's undefined. The range is still negative infinity to positive infinity because the streaks go up and down forever. Okay, now when we get into these reciprocal graphs like cosecant, recall that's the reciprocal of sine. In black ink, I have sketched in a couple cycles of the sine curve. Because of cosecant being its reciprocal, when you have a hill top in sine, cosecant's going to take that and run the opposite direction. Same thing's true for a valley. If sine has a valley, cosecant will take that bottom part of the valley and run the opposite direction. The red ink oscillation of valleys and hills is the graph of cosecant. Where sine is 0, you're going to get a vertical asymptote because 1 divided by 0 is undefined. So everywhere sine has an x-intercept, cosecant will have a vertical asymptote. The domain for cosecant is any angle as long as that angle is not a multiple of pi. And so I've got to be careful here, not equal to a multiple of pi. Be very careful as far as range. These valleys are defined for y values of 1 or larger. 1 or larger. Or anything smaller than -1. That range looks broken because it is. There's actually no graph of cosecant between -1 and +1. That graph exists at -1 or lower, and that's for these parts, or +1 and higher, and that's for these parts. The distance it takes horizontally to run one cycle is still 2 pi. You have a valley followed by a hill, and it takes 2 pi units to get it done. Only concentrating on the red ink, if you flip that graph upside down, it looks the same. So it has origin symmetry, and it's an odd function. Now, very similarly, for secant, that's the reciprocal of cosine. Again, cosine I've sketched in black ink, just as a reminder of what it looks like. The hilltops are where secant will start streaking upward. So if you've got a hilltop in cosine, secant will take it and run the opposite direction. And the same thing with the bottom parts. Wherever cosine has its low spot, secant will take that and run the opposite direction. X-intercepts of cosine will form vertical asymptotes of secant. Wherever cosine is 0, That gives you a denominator of 0, which is undefined. The domain of secant is any angle as long as that angle is not pi over 2 or a multiple of pi in any direction from it. This notation just means n is an integer. Those are positive and negative whole numbers, including 0. Similarly to cosecant, secant has a range of negative infinity to negative 1. Then the graph quits, and it doesn't start again until positive 1. And after it hits 1, then it goes up forever. So these arcs have a range of negative infinity to negative 1. The upper arcs are a range of 1 to infinity. It still takes 2 pi units to run a full cycle. So if you had a little hill and a valley, it takes a total horizontal distance of 2 pi for that to occur. This graph, if you fold it like a book, where the y-axis is the spine, the left side will lay right on top of the right side. So that's y-axis symmetry, meaning you have an even function. And finally, cotangent. You have streaks in the opposite direction. They're inverted. Cotangent is 1 over tangent. And instead of odd multiples of pi over 2 having vertical asymptotes, multiples of pi are where cotangent has vertical asymptotes. So its domain is any angle except for multiples of pi. Negative 2 pi, negative 1 pi, 0 pi, 1 pi, and 2 pi. Everywhere there's a whole multiple or an integer multiple of pi, you will find a vertical asymptote, and that means your function is undefined. These streaks go up and down forever, so the range is infinite. It takes a horizontal distance of pi to run one full cycle, and so the period is pi. If you flip the graph upside down, it will look like this graph right side up. And so you've got origin symmetry, which means it's an odd function. And an odd function basically means this. If you take a negative angle and go to its y value, when you go to the other side and find that opposite angle, which would be positive pi, you're going to have a negative. Check your e-text for details about all 6 trig functions and their graphs. They're consolidated in your e-text on one graph that shows domain, range, symmetries, graphs. The whole kit and caboodle is on one page, summarized very nicely. And so be sure to check that out in your e-text. If you have any questions, please reach out, email, phone, or just swing by the office during office hours, and I will do my best to help you out. Thank you.